Welcome to a new video. In this video we will discuss how we can solve equations. The outline of this video is shown here. We will discuss first linear equations, and in the second part we will discuss the quadratic equations. Alright, let's see first the linear equations. We'll discuss some examples and also illustrate that graphically. The first example is about the linear equation we have shown here. We have here 7x minus 1 is equal to 9 plus 2x. So we need to solve that. That means we need to solve the value for x. Of course, you can try some numbers and see if the left and the right hand side are equal to each other. That is trial and error. But the more structured way is by looking at the left and right hand side and using balance method. What does it mean by the balance method? Now you can see what we need to do is the following. We need to have at the left side only the unknowns, and on the right side only the numbers, so actually the constant. So in order to have that, we need to eliminate this 2x here. That means we need to also do that at the left side. So we need to subtract 2x left and the right hand side. That's actually meant by this. So we go down, that means we lose this. We only have 9 at the right hand side. We still have this minus 1 at the left side, but now this will be from 7x to 5x. Okay, now we need to also eliminate this minus 1. That means we only need to have here an x or something with an x. So multiplication. And this will be only then a number. So if we now add here 1, left and the right hand side, so we will have now 5x will be 9 plus 1, 10. Now we can solve this by saying, okay, 5 times x, so 5 times some number, must produce 10. So that number is then 10 over 5, so that will be then 2. So that is our solution for the example. How can we check that this is indeed correct? Now you can now substitute this in the left and the right hand side. So you can say 7 times 2 minus 1 must be 9 plus 2 times 2, which is shown here. So this will result in 14 minus 1, and this will be then 9 plus 4 will be then 13 is equal to 13. So this is indeed correct. Okay, in this case we also have only one solution. And this is now the graph. You can see here the graph, an x and a y axis here. So we see here the blue line and the red line. The red line is our 7x minus 1, which is now an equation. And now we have here also the 9 plus 2x. So these are two formulas. They have an intersection here. You see that at 2, 13. Now 2 is the x coordinate, the 13 is the y coordinate, so the x and the y coordinate. Okay, now we have this. Let's go now to the second example. In the second example we will discuss a little bit more complicated equation. We have now here parentheses, so we have here 4 times in the parentheses x minus 2 will be then 6 times in the parentheses 1 plus x. So how do we solve again the x? Again, you can do it trial and error, or you can do it a structured way. But in order to do that, like in example number 1, we need to first multiply out the parentheses. So we need to do 4 times x and then 4 times minus 2. That's what we have here. In a similar form, 6 times 1 and plus 6 times x. So we have here this. Now again, we need to eliminate the unknowns where we don't want it. So actually we don't want this 6x here. We also don't want this minus 8 here. So first let's start with eliminating this 6x. That means this and that will be also reduced by 6x. So we have here this one, so it will be then minus 2x minus 8 still will be only 6. Now I need to also make this 0, so I can only do that by plus 8. So it means this will be then 14. This will be only minus 2x, so x will be then 14 over minus 2. And that will result in minus 7. So this is the solution for this example. Let's again check that as we did in the previous example. So we can say let's put that minus 2, I mean minus 7 in here and also in here. So let's see what that produces. 4 times in the parentheses minus 7 minus 2 is equal to 6 times 1 plus minus 7. That means 4 times minus 9 is equal to 6 times 6 minus 6. And this is minus 36 and this is minus 36. So this again we have checked that. So the intersection point for this one, if we will draw the graph, will be then -7, -36. Okay, let's do another example, example number 3. In this case, we will discuss a system of equations, in this case 2 equations. We have 2 unknowns, x and y, so we need to solve for x and y. So how can we do that? There is a method we can use. In this case, we can make the coefficient for x or y the same. In this case, we'll see here 6x, but there is also here 3x, so they are not equal to each other. There's also not the same for the y, so we have here 2y and 4y, so we can multiply this, for example, just by 1, just leave it as this, and double the second equation. That's actually what we can do. So what we have is then, this will be then not changed, but this will then be doubled. So you see actually each coefficient here is double, so 2 times, 2 times, 2 times. And now we can say equation number 1 minus the equation number 2, and then we will have minus 2y minus 8y is minus 10y is equal to 9 minus 14 is then minus 5. So y is then equal to minus 5 over minus 10 will be 0.5. So we have our y. So now we can say substitute this value of y in one of the equations here. So that doesn't matter which one you take. So I will take the second one. So that means 3 times x will be then plus 4 times y is equal to 7. So 4 times 0.5. That means 3x plus 2 is 7. That means 3x is equal to 5 because you subtract now from the left and right hand side 2, actually as we have done here. So we have then x is equal to 5 over 3. Okay, now we have our solutions for x and y. Okay, we can also look at the quadratic equation. We have here example number 1. In this case, we have 3 terms, x squared plus 3x minus 4 is 0. We can factorize this using this method. The method what we use here is the following. You need to find 2 values or 2 numbers. If you multiply these 2 numbers, it needs to produce minus 4. And if you add those 2 numbers, need to produce plus 3. So we can say, if you didn't know that, so we go back, we can say, okay, minus 4 can be produced by 2 times minus 2. That's true. But if you add them up, that will result in 0. So we can again try to say, okay, let's do then minus 1 times 4, which is again minus 4, and then add them up, minus 1 plus 4, that will add up to plus 3. So that's the reason for having plus 4 and minus 1. Now the solution for this one is pretty easy because this needs to be 0 or that needs to be 0. So that means x is then minus 4. In order to make this 0, I need to have a minus 4 here. In order to make this 0, I need to have a x is equal to 0. X is equal to 1, I mean. Now this is the graph. You see actually here the graph, the red one. This is the x and this is the y-axis. You see here the intersection point. So the first one is minus 4, again comma 0, which is then our y coordinate. And here we see here 1 comma 0, which is from the x, and then there is also a y coordinate which is 0. So there are 2 solutions here. Okay, let's look at the example number 2 here. Example number 2 will also discuss another quadratic equation. In this case, we do not see that pretty easily what now the solution must be because the factorization here is not that easy. So we can use the ABC, the quadratic formula. So we can recognize the A is 2, the B is 3, and the C is the minus 4. So that's actually shown here. And now we can calculate first the discriminant, which is the D is equal to B squared minus 4 times AC. And we know the A, B, and C. So that means the D is then equal to 3 squared minus 4 times 2 times minus 4. And this will result in 9 minus 32, which is then 41. Now, the solution, the first solution, one of the solutions is x is equal to minus b plus the square root of d, which is this discriminant, over 2 times a. And if you do that calculation, we get now minus 3 plus the square root of 41 over 2 times 2, which is then 4. And that is approximately 0.851. Or you can have another solution, which is very similar to that one, only the change is this plus sign needs to be a minus sign. So we have this. So you just again substitute the value for b, the capital letter D, and also the a here. and we get here now minus 2.351. Okay, we have now here two solutions. Of course, this was really difficult to find by just factorization, so this is the method which will then work in all cases. Now we have our graph here. This is the red graph, which is then this equation 2x squared plus 3x minus 4. It is now intersecting this x-axis, which is our y0. We see here two intersections in this case again. So we have here this 0.85078, which is approximately this. And the second one is here the minus 2.37078, 0, which is then this approximate equation, solution I mean. Okay, this is also verified using the graph. So next one, the final example number 3, we'll discuss this equation. In this case again we will use the quadratic formula a, b, c, so we know a, b and the c is 4. Now let's again calculate first the discriminant d, which is this formula. Now, this is now 3 squared in this case, minus 4 times 2 times 4. Now, remember, this was before in example number 2, minus 4. So we have changed that to plus 4. Now, what we get is the 9 minus 32, which is then minus 23. So, do we have a solution now? Now, we know that the x values will be calculated using this formula. That means the square root of d is involved there. But if you have a square root of a negative number, you cannot produce real solutions. So that means we have no real solutions here. There will be, of course, complex values. In this case, if you look at the real solutions, there are no real solutions for this case. That means if your discriminant is lower, so smaller than 0, we will have no solutions, no real solutions. If it is exactly 0, we will have only one solution. And if you have a discriminant which is larger than 0, we will have two solutions. So let's also see that in the graph. This is the graph for this equation or this formula, 2x squared plus 3x plus 4. And this is the line here. This is the blue line, which is our y is equal to 0, which is the right hand side. You can see there is no intersection between this red and the blue line. All right, this was our video about the discussion of how to solve linear and quadratic equations. We have discussed several examples considering these equations. If you have any questions, comments, please let me know. I will try to answer them as soon as possible. See you next time in another video.